Okay, so a question out of energy metering, and this is using the CTs and PTs and working with the ratios of each one of them. So a PT is a potential transformer, the CT is the current transformer. In this case, what they're saying to us is that we've got a CT with a ratio of 3 to 1 and a PT with a ratio of 10 to 1. So let's just recall what they're doing. Over here, this is a picture of our CT right here. And so if our CT ratio is 3 to 1, what that really means is that we step down the current for every for every 3 amps going through that CT on the line conductor, we'll get 1 amp flowing on the secondary, so right here. And we're connecting that secondary up. In this case, it says to an amp meter, and we're reading it. It's 2 amps. And if we look at our PT here, so it's connected across line 1 and line 2, it ratios down the voltage. It's 10 to 1. So for every 10 volts here, I'm going to get 1 volt on the secondary here. So they're giving us readings off the secondary, the current readings. And what we got to do is apply these ratios and then apply a parent power formula. So if my amp meter reading is 2 amps, I have to apply the ratio 3 to 1. Okay. So 2 times 3, that means I've got a total of 6 amps flowing through this circuit right here. For the PT, it's a 10 to 1. So I've got a 90 volt reading on the secondary times up by 10. That is 900 volts from line 1 to line 2. Parent power of the circuit would be equal to the V times the I. So that'd be 900 volts times 6 amp. Should be about 5400 VA. Both of them are ratios, and what they're doing is they're ratioing them down to a safe workable level so that we can connect up energy meters to them. Okay. So PTs are they're used on circuits over 600 volt, right? Okay. And then instead of trying to have a great big energy meter that can do a 400 amps going through it, what they do is they just put in a CT that ratios it down to a workable level.
Okay.
So the normal secondary of CTs and PTs is going to be 120 volts. It'll ratio it down to, which is a nice working voltage for a PT. And the normal secondary is going to be 5 amps. And that's why I picked the next example, because they don't give you the secondary ratings. We have to figure out the ratios ourselves.
Okay.
So I'm going to go ahead to that next example. And this is it. So using a potential transformer with a primary rating of 2400 volt and a current transformer with a primary current rating of 400 amp, determine if the CT secondary, if the CT secondary is connected to the current coil of the wattmeter and reads 3 amps, and the PT secondary is connected to the voltage coil of the wattmeter and reads 80 volts. At unity power factor, the single phase power drawn by the load from the supply would be. So on this style of a question, we have to recall something. It's pretty hard to answer if you don't recall this. So the normal PT secondary is equal to 120. So I can figure out the ratio of this. It would be 2400 to 120. So that would be what, 20 to 1?
Yeah, 2400 divided by 120 is 20.
20 to 1? Okay.
Yep.
And then for the CT, we'll find out that ratio. So the normal secondary for a CT is 5 amps. Okay, it's a nice, safe, workable level. So at its maximum capacity, if it had a full 400 amps on the primary of the CT, it would put out a maximum of 5 amps because it's a 400 amp CT. So we can ratio that down 80 to 1, right? Now we're ready to take the readings off the second.
So we have to remember the 120 and then the 5 amps for the...
That is correct. You have to commit these to memory. That's the normal secondaries. Okay. So on our case here, what do they give us first? It gives the 3 amps first, right? So we'd have to figure out what is the actual primary current. It's going to be 3 amps times 80. So what would that be? 240?
Yeah.
Okay. And then 80 volts. Well, so 80 volts times 20 would be what's
1600.
1600 volts. Yeah. And now it says it's at unity power factor. So that means that the power of the circuit is equal to the S of the circuit. So I can just use volts times amps to figure this out. So the power will equal the voltage of the primary times the current that we calculated of the primary. So that's 1600 volts times 240 amps.
Okay. I was nowhere near this.
So what does that come to?
384,000.